Hello guys, welcome back to the channel. Please like the video if you find it helpful, and also make sure you subscribe the channel. So today I'll be going to solve a few problems on analog IC design. So this is the first problem which I took. So when we look into the circuit, the first thing which comes into our mind is this is circuit common source with source degeneration amplifier. And let's look into the data which is given. So when they have indicated that lambda is lambda is 0.1, so this indicates that there is a channel in modulation effect which is coming into the picture. And also they have indicated that gamma is non-zero, so this is an indication that there is a body effect which is present in the circuit. So the other data goes on. Now we'll solve each sub question one by one. So they asked is what is the required bias voltage of V in given that V out is 1.5 volts. So they are asking what is the value of V in so that V out would be 1.4 volts. So now we have to find this, what is that. So now let's start applying KVL on the input loop so that the KVL contains this variable which is unknown. So we'll start applying the KVL on input loop. So minus Vn plus gate to source voltage, that is VGS, plus I'll call this node as V. This is a source node, so I will call it as Vs equal to 0. So then Vin would be VGS plus Vs. We know that overdrive voltage is given by VOV is VGS minus VT. So then VGS would be VOV plus VT. Let us substitute this back into this equation. So then Vin equals VOV plus VT plus Vs. So now let us start finding each and every term one by one. VOV is already given in the question, which is 100 millivolts, so we need not find. Threshold voltage is something we have to find. The question has given VTHO, not VTH. So VT is the threshold voltage which includes the body effect also, VTHO plus gamma times of square root of 2 phi f plus BSB magnitude minus square root of 2 phi f. So when I substitute, I'll substitute all these values. Gamma is 1 and 2 phi f, the value 2 phi f is 0.64. they have given this value 2 phi f 0.64 plus, and VSB we shall find the value of VSB. VSB is Vs minus VB. So we know that in a NMOS the base is the body is always connected to ground, which is 0 volts. So VSB would be Vs. Now let us find what Vs. So Vs is from the circuit, Vs is, so this is the Vs. So Vs is ID into Rs. We know that Rs is 500 ohm, which is given here, so I'll write it as 0.5k, and ID is something we have to find. So ID is something, the current which flows through RD also. So from here, like, I can find ID. So ID is VDD minus V out divided by RD. So we know what VDD is, which is given in the question, 1.8 volts, and V out they are mentioned in the sub question, which is 1.4 volts, and RD is also 500 ohms. So when I substitute all these values, I will end up getting 0.8 milliamps. So I'll for Vs, So Vx equal to 0.8 milliamps into 0.5 kilo ohms. So we'll get Vs as 0.4 volts. So we got VSB as VSB is nothing but Vs, which is 0.4 volts. So I'll substitute here 0.4 volts, and this 25F is the data which is given in the question itself. So when I evaluate this, this would come as around 0.62 volts. So now already we have obtained board drive voltage, and also we have just now obtained threshold voltage. And also meanwhile while evaluating threshold voltage, there had been a scenario we had to obtain the source voltage also. So we got the source voltage also, which is 0.4 volts. Now let us substitute back in Vn, which is VOV plus VT plus Vs. So VO is 100 millivolts, which is 0.1 volts, and threshold voltage which just now we obtained, which is 0.62 volts, and source voltage, which is Vs, is 0.4 volts. When I substitute all this value, I'll get Vin as 1.12 volts. This is what the answer for the sub question 1. So we are able to obtain the Vin. So the next sub question is, they are asking whether transistor operates in saturation region or not. So we know that for NMOS, in order to operate in saturation, we have an equation which has to be satisfied: VDS greater than or equal to VGS minus VT. So VGS minus VT is nothing but VO drive. So VDS is VD minus VS, and VO drive, we know that they have given as 100 millivolts, which is 0.1 volt. Now we have to obtain what is VD and what is VS. We know already VS is 0.4 volts. Let us obtain what is VD. Now going back to the circuit, VD is nothing but the terminal voltage at the drain terminal, which is here VD. So since VD and Vout are at the same node, we can say Vout is nothing but VD, so which is 1.4 volts. So now I'll substitute to this inequality, and based on that so VD is 1.4 volts. 1.4 minus 0.4, checking whether it is greater than or equal to 0.1. 1.4 is 1, so 1 is greater than 0.1. So we can clearly, conclusion is MOSFET is in saturation. This is which is asked in the sub question B. Now let us go into the sub question C. What is the gain of the amplifier? Sub question C. So they are asking the gain of the common source amplifier with source degeneration. We know there is a direct formula which is gain equal to minus GM RD divided by 1 plus GM times RS. We know RD and RS is given in the question. ID is the something which we have to find. So let us find GM. So GM is one of the equations for GM is 2ID divided by VOB. ID we have found it as already 0.8 milliamperes, and VO drive is something which is given in the question already. So when we evaluate this would come as 16 millisiemens. So when I substitute all the obtained data into the gain equation, 0.5k 1 plus 16 milli times 0.5 milli, So gain would come around as 0.88 volts per volts. So the final gain is minus 0.8888 volts per volts. So this is what which was asked in the sub question C. Thank you guys.